Mm. All right, welcome everybody. And give folks a few minutes to join, and then we're going to do a quick intro about Acelab, show you how to get in touch with today's presenters. After that, we will proceed with our CEU course for today, Rooftop Snow Retention, Solving the Mystery with Facts. We've got Mindy from TRA Snow and Sun here today, who's going to be presenting our AIA-approved topic. All right, looks like we've got a good amount of folks jumping in. So without further ado, Helen, feel free to take it away for a quick intro.
Awesome. Thank you, Bo. Hey, everybody. My name is Helen, and I'm the Director of Architect Experience here at Acelab. Today, I'm going to show you how to get in touch with Mindy and also save their products to your projects. And then I'm also going to jump in and show you something that we have released to some folks for early access. And if you're interested in joining us for that too, you can meet with me and we can get that started. So first things first, how to get in touch with the wonderful Mindy. So anytime that you're looking for something in Acelab and you know the brand name, you can always type in, the first few letters there, and then you can go to brands here, and then I'm going to go to TRA Snow and Sun. What this will do is it will have the overview. If you want to get in touch with Mindy, you can hit contact here. What that'll do is start a conversation in Acelab. So whatever you need, she will respond very quickly there, and you'll see that kind of notification here. You'll also get an email as well. You can also respond directly to that email. You don't even have to log back into Acelab. Scrolling on down, you're going to learn a little bit more about their products. And then here is going to be where you can save all of their different clamps and systems and things like that into your project so that then you can create comparisons and, kind of carry on with your project list. So you can see there's lots of stuff here that you can save. Down here too, you're going to find some additional information, case studies, inspiration, and then a little bit more about the company and where they're located down here. So really recommend saving their products in, and what that will do with the early access item here. I'm just going to jump in. Everything that you now save into a project, you'll be able to see comparisons, but you'll also be able to pull it in to a schedule here. So lots of options of what this looks like and lots of options and ways that you can use this. Right now, I'm looking at this through a firm library lens. I'm just going to jump into this one. What this allows you to do is say, hey, this is always the standard installation we use. You can export this as a CSV. One of the great things about using this as a library is, let's say you get a new project, you can just come over here, select those products that you want to use in your next one, and then you can just copy and paste them into your next project. Lots of other handy ways that you can use this. You can set up client libraries. So, repeat clients may be applicable to today's topic as well. You could set up geographies. So, maybe your firm has projects all over, but you could set up a tag for, I don't know, Mountain West or something like that. And then when you have that selected, you'll know that you should be looking at maybe the TRA Snow and Sun systems for snow retention. So if you want to learn more about this, this is coming out to everybody in September, but we are doing early access right now. So what that will look like is you do a 30-minute meeting with me. I learn a lot more about you, your firm, your goals, and then we kind of come up with a tailored way to use this. Again, this is a library use case. There's also some really fun ways you can collaborate with your clients and track approvals, and also kind of get bid sets and stuff ready for contractors. So lots of ways we can take this, and I look forward to meeting with you. I'll pass it back.
All right, awesome. Thank you so much, Helen. A few quick housekeeping items from me. This is an AIA-approved event. We ask for AIA numbers upon registration. We'll also send over a form in the chat momentarily where you can give us your AIA number and request a certificate. Other than that, just want to encourage folks to please ask questions throughout today's presentation in the Q&A. We should have some time to get to those live, and if we don't get to your question live, we'll have a record of it so we can follow up with you after today's event. All right, that's all for me. Mindy, whenever you're ready, feel free to go ahead and take it away.
All right, sounds great. I will go ahead and get that started. And can you see my screen?
Not yet.
Okay, there we go. Yep.
Perfect. All right. Well, my name is Mindy Dahlquist. I am the business development manager at TRA Snow and Sun. And basically anymore, that just basically is a full-time educator for TRA to help everyone to understand their products and just understand what snow retention is, how it functions, and how it should be utilized on a roof. So this is an AIA course, as Bo had mentioned. If you do need those AIA credits, please just make sure that you've checked that area requesting the certificate so that we are able to make sure that you do receive that in a timely manner. Otherwise, if you don't receive it, that's not a big deal. Just reach out to me or Bo or Helen, and we'll make sure to get that to you. So all of this information that we're going to provide you with today has been researched, assembled, and is provided completely by TRA Snow and Son. So if you have any questions, concerns, anything like that, definitely let us know. We're a pretty small company still, so we're always more than happy to look into any kind of specific projects or specific issues that you are having on your project. This course is going to provide an in-depth look at the safety issues, the problems, some of the solutions that are associated with snow and ice moving on the roof. We're going to focus mostly on the heavy snow accumulation areas. So we're going to look more like the mountain regions and those types of things specifically for this presentation, but that doesn't mean that snow retention is only necessary in those heavy snow regions. This is just what we're going to focus on for the training, because that's where the proper engineering and installation is really going to come into play when you're holding back a large amount of snow. So this course is designed to help the professionals bridge the gap that's currently there by the lack of codes and standards relating to snow retention at all. I'm sorry, I believe we just lost that. But currently, there's just no codes, no standards in the industry at all to reference snow retention, even in areas that it's completely necessary. So due to that, we're kind of just guessing when we're placing snow retention, maybe some here, maybe some here. We want to protect this area, and that's not always the best option. So at the end of this presentation, you will be able to realize that codes and standards relating to snow retention at this time are completely non-existent. You'll recognize some of the common hazards and damages that are caused when heavy snow does accumulate on the roof. There's some everyday solutions, some do-it-yourself kind of practices. We'll kind of compare and contrast those and see what works and what doesn't. There's also modern snow retention systems compared to what snow retention originally started at. So we'll identify each of those in a very basic form and understand how they function. We also will go over some of the things that need to be considered while engineering a snow retention system. And then if we have a little time left over, this is just kind of a little special thing that is added into the presentation, talking about ice damming and how design factors can actually help eliminate ice damming. We'll go ahead and start this little video here. It might come across a little loud, but you'll have control of your own volume. If you can hear it, it's going to come through my computer.
Second is how long it took for snow to fall off the roof. The toddler and two 7-year-olds were buried in that snow.
It takes more than just a row of snow guards placed haphazardly on a roof to prevent tragedies such as these.
I'm not sure what just happened there. Well, it looks like my computer has just frozen completely. I am just on it for technical difficulties today.
Oh, goodness. Well, yeah, feel free to go ahead and quit out, and I can take care of a few housekeeping items while we wait.
That
Thank
is
you.
perfect.
All right, cool. So real quick, I'm gonna go ahead and grab this form for everyone. Cute background. All right, cool. So over here now in the chat, I am going to go ahead and send the form to submit AIA numbers and certificate requests. And yeah, it looks like we might be back up and running. So
Yes.
perfect
We
timing.
are good to go. I am not going to finish the video just because I'm concerned that that's what stuck us there. But basically, from what you could see on that video, we are talking about heavy snow accumulation. This is not just a little skiff of snow. This is definitely on the high end of snow accumulation. This is in the Lake Tahoe area in the Sierra Nevada. So a lot of their snow loads can be in the upwards range of 400 to 465 pounds per square foot. So when you're designing in these areas that you're maybe not as familiar with, really taking those snow loads into consideration and making sure that the structure is prepared to hold them is going to be the most important thing, even if you're not including snow retention. So some of these houses are going to maintain very large loads of snow on them. And then it's just a given time. There's really no exact time that that snow is going to let loose off of that roof. So making sure that it's always designing to the worst case scenario when you're looking at heavy snow accumulation areas is very important. But we're not looking at just a light little skiff of snow. When the snow gets heavy and does accumulate on the roof, it glaciates. So it doesn't even have to be heavy at that point, but it will actually freeze into one giant large mass on the roof. That snow gets heavy and hard. It does not stay light and fluffy. So since there are no codes or standards that currently exist for the engineering, manufacturing, or installation of snow retention systems in both the US or Canada, with the building codes being completely silent about this, it does result in at least the following that we're currently aware of. The first thing is going to be snow retention companies at this time can manufacture their systems however they want and out of whatever materials they want. So if I wanted to take 500 tubes of chapstick and sell it to somebody and tell them they just need to super glue that chapstick to the roof and it's going to hold the snow back. Currently, there's nothing stopping someone from calling that a snow retention device. So it just kind of brings up a lot of problems. There's a lot of little tiny plastic clips and all different things that are coming up and that have been around that may not function properly, but they're still being sold because there's just no standard to reference. Municipalities also have a difficult time codifying that snow retention since there's no standard to reference. Without a standard, if a city knows that snow retention is most likely the best option for sidewalk areas or doorway areas, it still doesn't give them anything to call a snow retention system. At this time, do you put one bracket up? Is one bar enough? Is 2 bars enough? Do you need multiple rows of 2 bars? There's nothing to tell you, okay, for X, Y, and Z, this is how much snow retention you need to have on this building. And due to that, owners just don't want to pay for it a lot of times, even when it's needed, just because it's not required by a code. Architects also have a difficult time knowing exactly how to specify snow retention. I will say the last 2 points there, I feel like have just gotten better and better over the past couple years on snow retention becoming more and more consistent with metal roofs and a lot of the slippery roofs. And so it is getting much easier to have the conversation, but there's still no codes for anyone to reference to be able to say this is officially what you need unless you're working with a snow retention manufacturer. So some of the common hazards and challenges that are caused when snow does move on the roof is going to be personal injury and death, which is obviously the most serious one, damage from sliding snow and ice, premature aging. I actually had an architect ask me one time if premature aging was for the roofing material or for the homeowner. It really just depends. If you've ever had to replace your roof, I'm sure it probably gave you a few gray hairs, so that's fair enough. But otherwise, we're talking about premature aging on the roofing material itself. Limited and restricted access and views, and then ground snow removal. So I have 3 videos here. I'm scared to play a video just because of our little mishap there a minute ago. So I'm just not even going to go into these, but each one of these videos are in different areas. One of them is in Idaho, one is in California, and one is in Utah. They are all different deaths. One of them was multiple people, and the other 2 were single people. And it is something that happens every single year in snowy regions. and it's due to rooftop avalanches. And in each video, they call it a freak accident, which I feel like if it's happening every single year in different areas, year after year, it becomes something that's a little bit more serious than a freak accident, and is something that we believe is completely preventable in most cases. So we'll just skip through those videos for now. If you ever want to watch them, I can send them to you. That's not a big deal. And we'll go right into the damage from the roofs, or damage to the roofs from the snow. The snow sliding down this metal roof here has just caused some damage on that dormer, and that happens very, very often. You're taking the force of that snow and just shoving it into the side of that roofing material, and it can most definitely damage it. Certain design factors, such as this double valley here, can also help funnel that snow into the roofing material in a way that can damage it as well. So these metal shingles here have just been completely crumpled up like they were tinfoil. Any penetrations on the roof, we're very much aware that these are easy targets to sliding snow and ice. This is why oftentimes things like crickets are installed on the roof. And this is something that a lot of times that PVC pipe on the lower picture is actually just sheared right off, but it looks like they maybe forgot to screw that down a little bit. But even the metal pipe that's used for electrical wiring penetrations, that metal conduit up there can very easily give way to sliding snow and ice. So it's forgotten about how much snow can actually be on the roof and how much that snow can weigh quite often. So those penetrations are definitely up there fighting for themselves. When the snow sheds from an upper roof to a lower roof, it definitely can cause some additional damage to the roof as well. This picture is a little hard to see, but that standing seam up at the top of this panel here is quite damaged. And then as you get down towards the eave, there's a nice little pattern going on there that should not be there. So it definitely has been impacted from the sliding snow and ice from up above and hitting that panel and just crushing it. When the snow freezes to the roof and then moves, it can very easily damage the roof by taking part of that roofing product with it. And then stuff like this happens very often where it's just kind of a crazy circumstance. The snow has slid off the roof and has actually pulled that panel off with it, whether it didn't have enough clips holding it, or if they weren't placed properly or not placed at all. We may never know, but this is something that just shows how fast that snow moved off the roof because that panel was never even bent. So this photo here is kind of interesting. These are cabins side by side. They look pretty identical. One has snow retention, the other does not. Unfortunately, the one that does not have snow retention no longer has their deck enclosure either. So at least they'll be able to just go over and push that snow off the ledge there, but otherwise it's kind of a little bit of a dangerous situation to just have that kind of opening coming off of your deck. This kind of just shows where the snow can fall on the gas meters. This is something that's taken into consideration in many codes currently. So this problem has been helped by a lot of those code changes for snow shed areas. But if you're doing any kind of remodels, things like that, always be cautious of where the gas meters are located and that they're not going to pose any kind of danger. In Sun Peaks, Canada, this was just a couple years ago, I believe, where there was a home that the snow had shed off the roof onto the gas meter. The homeowners went out, dug everything out. It looked to be structurally sound. And so they went on with their life. And I believe it was 3 days later, they were all at work and at school, and their house actually did explode. So that's something that can happen. It doesn't happen as often because of the precautions that we're taking currently with our new designs. Structural damage doesn't always have to include the roof. It can be many, many things around it. So something like windows. This is something that we would call creep and curl. And what is occurring on this cabin here is the slope of the roof is not steep enough for that snow to quickly slide off. And so what happens is the ridge, so up at the top of your roof is where you have the majority of your heat loss that occurs. And as it begins to melt and slide that snow and water down towards the eave, you're going to have a refreezing that happens because those eaves are much, much colder. They get a lot of airflow that run underneath them. And so it's just going to be a colder temperature. As that snow comes down to that eave and refreezes and gravity is still pulling it down, it's not going to just shoot off that roof. So it can continue to just creep down and curl underneath. And this oftentimes does result in broken windows. Things like vehicles, animals, trailers, all kinds of things can also be damaged from snow and ice sliding off of the roof. Neighbors' solar panels, the neighbor's fence. We get those kinds of calls all the time where a situation, it isn't even your things or your, I want to say problem, but it is most definitely their problem still, but it's sliding off of their house, and it may have been designed to shoot right off their house, but where it's hitting isn't always factored in. And your neighbors apparently don't love it when you're always breaking their things. So something like cars here. So the photo on the left this is in New York City, and this is a multi-story building that the snow and ice had let loose on, and this man was walking to his vehicle. And luckily he was not yet inside, was not injured, anything like that. But that's not a fun conversation to have with your insurance company. The photo on the right, this is actually a hotel that was being remodeled at this time, and the snow retention that they had utilized was some handy PVC pipe. So something that you would utilize for plumbing or irrigation is up on the roof holding back thousands of pounds of snow until it mashed in everyone's windshield. So not a good day for those people, and probably not for that hotel employee that had to talk to all of them as well. This photo just shows how much that snow wants to stay together once it's already become that glaciated mass. Premature roof aging, I feel like this section is pretty self-explanatory. You have the snow and ice that's up there. There's a lot of freeze-thaw cycles that are happening on that roof. You've got a lot of repeated expansion and contraction. All that's going to do is pick up some of those fibers, try to lay them back down. They can't go back down. And same thing with metal roofing materials and other types of roofs that have protective coatings on them. That snow and ice is just going to act like sandpaper up on that roof as it kind of just sits there and slowly moves around. Any entrances or exits, windows, all of those things can be blocked by snow that does fall off the roof. So this door is behind this pile of snow. It's heavy, it's hard as concrete. If you've ever had to get into these piles of snow that have been sitting there for a while, it is not going to be easy. It's not something you're going to do with a shovel, and a piece of equipment. Getting that close to your house or cabin can be pretty sketchy. So it's not a good situation to be in. You also limit access to necessary areas of your property. This cabin was built with snow shed in mind. And so they decided, we're going to have this beautiful cabin out here in the mountains, and the snow is going to shed off the roof because we don't want that roof to collapse. But unfortunately, it blocks their main walkway from their garage and from their parking area to their house. So if they have friends or family over, they're going to have to make sure that they're out there to guide them on how to walk through their entire house to get there versus walking through that pile of snow. This was a homeowner that knows that they have a problem with sliding snow and ice, as you can see from the many crickets, and they started to have issues with broken windows and decided that they would install their own do-it-yourself kind of barn-style window coverings. This is a great, great idea. Unfortunately, just did not work so well for them. They still have 2 broken windows, a broken window covering, and you're just taking away that beautiful view to the outside. And you still have a giant pile of snow in the yard. So there's a lot of things that come into play there. And then oftentimes that snow that does build up on the ground from your roof shedding does need to be removed in a lot of cases. This can be extremely costly, time consuming, and labor intensive. When I first moved to Utah, I did heavy snow removal. And the first storm I hopped out into was 26 inches. And I believe we were charging $350 per hour per piece of equipment. So that just gives you an idea for a commercial building how expensive this could be. And for a homeowner, the unexpected cost I mean, $350 an hour and multiple hours to do this. This isn't something that they're just going to go out and scoop one scoop and they're on their way. It's going to be very time consuming. So there's some everyday solutions, the sign approach, the caution tape approach, and manual rooftop snow removal. So let's take a look at those. There's a sign approach. I see these all over the place, Colorado, Utah, California, a lot of places that are very heavy snow areas. And some do choose to simply put that sign up every year or leave it up. But unfortunately, when it comes down to a lawsuit and you walk in and you sit in front of a judge and say, well, I had a sign up that said danger, falling snow and ice from the roof, walk well or park clear, they're going to say, so you know you had a problem and you basically chose to do nothing about it. This is kind of a Band-Aid type of solution. And oftentimes, mostly business owners and things like that are not going to fare well in those situations. It does not remove any kind of liability from the owner, and it definitely doesn't stop any damage or injury. I was in Durango, Colorado, a while back for a training, and I was pumping gas in my rental car, and I'm done pumping gas. I go to put the gas nozzle, I've lost the word for a second. I go to put the nozzle back and I look over and there's a sign directly right there that says snow falls, be cautious. The whole time I was pumping gas, that snow could have very easily fell on my head and I would have never noticed until I was buried in there, because that's just unfortunately how the signs work. There's so many signs now. Same thing like here. Sometimes those signs are put in very interesting places. So a handicap parking spot, ADA accessible, should be easy and safe to get in and out of a building, except just be careful in your wheelchair because there's a very prominent danger of the roof that sheds snow and ice randomly at any given time. So these types of things definitely need to be taken into consideration while designing. Caution tape approach is something that is utilized quite often with snow shed as well. As you can see in this photo, it doesn't always protect anything, and that caution tape will very soon be covered up and completely ignored. There's, I believe for the Winter Olympics in Canada, there's actually a winter gathering area that is ski in, ski out. You can sit there and have hot chocolate at the fire pits with your family. Brilliant idea, except for every time it snows, the snow sheds off the roof and sheds directly onto that winter gathering area. So no one can actually get in and out of there, and they caution tape it off completely. So make sure if we're building winter gathering areas that they're able to be gathered in the winter. I don't want to get into the videos just because of the concerns with those videos pausing earlier. This was just going to be a funny little blurb of a guy who gets taken out by the snow and is completely safe and laughs it off at the bottom. But manual snow and ice removal, as I mentioned, it's really expensive to have someone come and move snow, whether it's on your roof, on the ground, it doesn't matter. It's going to be very costly. It's also extremely dangerous to be having someone shoveling snow on your roof. Roofing is a dangerous industry to be in as it is, and then you add snow and ice to the mix, it gets very slippery and you're at height. So it can be quite dangerous. I believe in Utah last year, the mayor of one of the cities, they had a death due to a guy who was shoveling snow off his roof, and it completely surrounded him. And after that, the mayor was telling people that if they were hiring someone to clear their snow off of their roof, that they needed to have like a little cherry picker or a lift right there, a bucket lift, so that they could fall into it when they slid off the roof. So it's a very dangerous thing to be doing, and it's not something that we want to see anyone get injured from. The guy in the middle, I'm not exactly sure what his end game is. I don't think gravity is about to be on his side, at least when it hits that ladder. The photo on the right just shows you how much manpower, how many people it takes to be able to get the snow off of a property and what that looks like. I guess we are going to play this video because it just started playing on its own. This is in a different country. This is just here to show you how fast this happens. This guy's up there and he's perfectly fine, and then he's sliding clear off the roof. So fortunately, he is okay. Probably is going to need an extended lunch break, but he is good, and they just tell him to walk it off. I don't think that's what you're supposed to do when someone has a fall like that, but I guess he'll rub some dirt on it and get back to work. I hope you take my very dry sense of humor in a positive way. I like to try to keep this entertaining and educational at the same time. So let's take a look at a few design practices in the US and Canada as potential solutions. Generally in the US and Canada, structures are designed with a steep sloping roof in the mountainous regions and a lower slope in the lowlands. Steeper roofs do allow for it to slide off more easily, but unfortunately, it's kind of designed around the snow itself and doesn't effectively address any of those issues that we've just talked about. So Europe, and I'm not going to say that everything that they do design-wise is completely the perfect solution, but their design strategy is exact opposite actually of what we do in the US and Canada. They do choose to use a low slope roof in mountainous regions to prevent further damage to the roof, as well as retaining snow on the roof as an insulating blanket. So with that, they're promoting energy efficiency, allowing for even melt off to the snow, allowing safe access to any residents and guests, gets rid of that damage issue for the property and the roof below, or the roof and the property below. And then you're just helping to limit those liability issues, save some money with your energy efficiency, and just kind of gives you architectural freedom as well to put those entrances and exits, windows, and all of those things in the building wherever you would like. And actually in Europe, they design complete opposite as well in the lowlands. So in the lowlands, they actually have steep sloping roofs because they use no sheathing. So they want to get that water off of there very, very quickly. So I mentioned less design freedom if you are shedding the snow a little bit, but then you're also losing that snow as an insulator as well. Snow does have R value. It's there. We might as well utilize it for something positive if we have to live through 6 months of snow. Dormers, whether they were ever intentional or not, they actually do work very well to hold snow in place or divert it once it's already moved. They can protect those areas down below as well. Unfortunately, though they can be structurally effective at diverting that snow, they're usually not built to be able to withstand that force and the weight of the moving snow. So that roofing material is not made to take random impacts beyond something like hail or something very small. When you're talking about moving hundreds and thousands of pounds of snow on the roof, it becomes a different ballgame. I said hundreds and thousands, by the way, not hundreds of thousands. I just wanted to be very clear. I said that and I was like, that sounded concerning. Another problem with dormers is they do create more areas of the roof that will alternate regularly between sun and shade. So you're just having more freeze-thaw cycles in this area. This adds potential for a massive ice dam, basically. If you have something like an ice dam coming in, that ice buildup can lead to leaks and other damage that will just add to a whole lot of maintenance year after year on that property. So we'll take a look at roofing products and what kind of effective solutions they can be. I'm going to kind of roll through these pretty quickly, so please don't hesitate to speak up if I am going too fast or we need to jump into something else a little bit more. So when it comes to snow, some slippery roofs are just going to allow that snow to slide off much more quickly. Those roofs are going to be like metal roofs, composite and synthetic roofs, eco roofs, and single ply roofs. These roofs alone are not going to be effective at stopping snow from moving at all. I would probably also add something like concrete roof tiles, those types of things in here. They honestly are very, very slippery. This is just a quick little snippet, a little story actually about the Dallas, Texas stadium. So it's game day in Dallas, Texas. There's a very small amount of snow on the roof of the Dallas, Texas stadium, and it actually slides off. It hits 6 people. Those 6 people filed a lawsuit against them, and they did win. And due to that lawsuit, the Mercedes-Benz Stadium, who was managed by the same management company, they actually put it is completely over the top. It's like a 4-bar custom snow retention system on the Mercedes-Benz Stadium, which is in Atlanta, Georgia. So in an area where the snow isn't very prominent, they decided that it was made much more sense for them to put an over-the-top snow retention system up than to risk another lawsuit that they experienced in Dallas, Texas. So other roofing products are not as slippery, and snow just doesn't easily slide on them. It doesn't mean it doesn't slide on them, but it's just not as simple as something like a metal roof. Those would be tile and slate, but if you think about slate, slate is still very, very slippery with snow. Wood shingles and shakes, there's a little bit more abrasion there, a little bit more grip. Asphalt shingles, it's often thought that snow does not move on asphalt shingles, and that is something that gets proved wrong year after year. And then rock coated metal shingles. So are they effective at stopping snow from sliding? I will flip through these pretty quickly because they are just not. There's concrete tile that is busted up, wood shingles and shakes, and they're just not as slippery as the tile and slate, but it definitely still can move on there. And the asphalt shingles, this is one that we get year after year from a homeowner of, how do I solve this problem? The snow keeps sliding off and hitting my neighbor's solar panels, or is taking my deck railing off. But what's happening there is the snow is usually going to slide on these roofs at a different time frame. So it's usually going to be in the spring that melting starts to occur. We start to get really warm days, but then our nights are much colder. And so what happens is you have water that starts to run underneath that snowpack. That cold night comes in, it's freezing, and now it just gives it that perfect environment to slide right off. There's nothing gripping to that. You have a solid sheet of ice underneath that snowpack, and that snow can move off very easily. So basically, all roofing types in their own way have problems associated with moving snow. So understanding modern snow retention systems, a good thing to help understand snow retention systems is knowing that snow retention isn't something new. This isn't a new idea. This isn't something that we came up with. We did come across the idea over 30 years ago in Europe, and that's how we started designing snow retention systems. So the idea of retaining snow on a roof and keeping it from moving or falling off is not a new idea. This is something that has been going on for centuries. I believe in Europe and also in some Japanese cultures or in some Asian cultures, it was very, very often that there were rocks or boulders placed on the roof, oftentimes even logs that were used for this purpose to be able to hold that snow and allow it to not slide off. I don't know that I want to be hit in the head with a rock any more than a pile of snow, but using what you have is very important. So the common types of current modern day snow retention devices are snow brackets and snow fences. Snow brackets are also known as snow stops, snow cleats, snow clips, whatever you want to call them, that's perfectly fine. For today's presentation, we'll call them snow brackets. They lie directly on the roof surface. Generally, a bracket will cover the entirety of the roof. So they usually will mount to the sheathing, the battens, or the roofing product itself. Where snow fences, we'll go into their characteristics a little bit, but they are completely different than what a bracket is. Snow fences will clamp onto the roof's metal seam if it's a standing seam panel, or they mount directly to the deck. So a lot of the snow fences will actually go into structure. So they need to be attached to the rafters, the trusses, or the purlins. Brackets themselves, so they are made about 3 inches deep, and that is designed specifically to help penetrate 3 inches into that blanket of snow on the roof. The snow then freezes to that bracket, so it results in one large glacial mass held in place by the brackets. The most important characteristic of snow brackets is they are designed to stop snow from ever moving. They are not designed to stop moving snow. So one row of brackets along the eave on a roof is a really bad idea. Unless that's what was engineered and what was called out for that specific project, you definitely need to reconsider, because brackets are made to be staggered from eave to ridge and to be in that pattern to make sure that it's holding that whole mass in place. That snow is not made to come down that run of the roof and slam into those brackets. It needs to be able to freeze before it ever moves. They also do allow for a little bit of area between the blanket of snow and the roof surface. That just allows for the melted snow to drain properly while those brackets are still frozen 3 inches into that snow mass. Snow brackets can be designed for most roofing products. These are just some examples of what they can look like. Where snow fences and their characteristics are a little different. So they are made to take a little bit more of that impact. And so you still want the snow to freeze to the fence, but the snow fences and brackets can be utilized together in certain situations too. If you're looking at heavy snow loads or pretty steep slopes, then utilizing brackets and fences together is brilliant. If one fence isn't enough, then multiple rows can be utilized. It's oftentimes thought that these fences are much stronger. Something like a deck mount fence that's going into structure is going to be very, very strong. But a snow bracket is actually kind of, in my opinion, and due to our testing numbers and things like that, and competitors as well, we're finding that these brackets are much, much stronger, and they do need to be used in uniform and as a team, but they are very strong even individually. Deck mount fences that attach to the structure. This is just a quick drawing of this, where the clamp-on fences clamp to those seams without puncturing through the seam of the roofing material. Snow brackets and fences can be used for almost all types of roofs. They can be made from various materials. Oftentimes it is steel, copper, aluminum. They can be powder coated to match most roof colors. There are a lot of factors that go into the engineering of snow retention systems, and the amount of weight that's going to be held on the roof is normally the first question. We determine that by finding ground snow load. So we're doing that because we want to utilize the worst case scenario of the situation. Ground snow load is going to be lightly defined as the heaviest accumulated snowfall in the last 50 years. And since all of the snow will be held on the roof, ground snow load needs to be used, not design snow load. And then, are the buildings going to be strong enough to support the weight of the snow? Well, snow loads have been taken into consideration in building codes since the mid-1970s. Any buildings built prior to that definitely need to be checked out by a structural engineer before installing any kind of snow retention. So if you've got St. Mary's Church down the road that's doing a full remodel and it's a beautiful building from the 1800s, please do not put snow retention on it prior to having the structure looked at, and make sure that a structural engineer okays that before holding any snow on that roof. Snow retention engineering factors are going to be, what is the product? So what kind of roofing product is on this roof? Is it metal? Is it composite? Is it asphalt shingles? How strong are your fasteners and how thick is the sheathing? So knowing what kind of fastener you're putting into that snow retention device is important, and what kind of sheathing that you're going to be using. What is the force of the snow on the retention devices? What is the weight of the entire snow mass from eave to ridge? What kind of slope are we talking about? Is it a 212 or is it a 1212? What is, and how strong is that individual snow retention device? So as I mentioned, currently, if we wanted to sell snow retention as chapsticks, we could. So how much weight can that one individual chapstick hold back? So while engineering your snow retention systems, there's some information that you or the roofer or whoever else may know or be able to look up, such as the ground snow load, the slope of the roof, roofing material, sheathing, or rafter truss spacing. But since there's no codes or standards to be able to reference, some things cannot be known and can only be determined by testing, such as the strength of that retention device, the pull-out strength of the specific fasteners that will be used, and the fail point of the system. So if the snow retention companies are not testing their products and systems in order to have that data, there's no way for them to engineer any kind of system. I'm going to just skip by that. That was just a quick test of a snow bracket. And to ruin it for you, the failure is at the fastener in most cases. A lot of times the fastener pullout will happen if there's not enough brackets on the roof. And that is why it's very, very important to engineer those systems if you are including snow retention. All of those factors need to be indicated, and all factors on these projects that I'm looking at currently on these two graphs are exactly the same, except these two projects are perfectly the same minus the sheathing that will be utilized. So the project on the left is 7/16 wafer board. The project on the right is 3/4 inch CDX plywood. And as you can see, the number of brackets to install per roofing square goes completely from 23 to 11, depending on which product is utilized for the sheathing. So this is why it's very important if you're doing two projects side by side, and let's say they're just going to be different owners or they're built at different times, so there's different materials that are being utilized, or you had to go a little cheaper on one to save some money on the budget, and sheathing was something that did get changed, then it's important to make sure that you're getting a new engineered layout. Otherwise, you could be installing twice the amount of brackets necessary or half as many that is necessary to actually hold the snow back, and you could see failures. This is just a little example of what the snow retention layout can look like. And I mentioned that those will be in a staggered pattern from eave to ridge. And this is more of what a fence layout would look like. If a snow retention system is not engineered for those variables that we discussed, you most definitely can see failures. We'll run through some quick failures on this. I just don't want to take too much time on this. It's something that happens all the time. You can drive down the road in any mountain region and see snow retention that has failed. Plastic bracket failure is the easiest and most common one. I don't think I've ever seen a plastic bracket project that had all of its brackets up on the roof still, and you just have those little Band-Aid adhesives. So many, many failures of snow retention can most definitely happen, even with the strongest of materials, if you are not considering those factors. This one here, those brackets are not made to take that impact. These were manufactured out of 1/4 inch plate. And this was somebody's do-it-yourself situation of they saw snow brackets, they can make that themselves. And unfortunately, without engineering on that installation, they were actually ripped out along with the sheathing. PVC pipe should not be utilized as snow retention, and deck mount systems should be going in with a lag bolt, not something that's made to hold a mirror on your wall. Partial installation is the biggest and most common reason that you will see failures of snow retention. Just covering a doorway or a walkway, a window, a garage, something like that with snow retention allows for that whole force of that blanket of snow to be held by a very minimal area of snow retention. So in these photos here, that whole run of the roof is being held on those last final ribs, and the ribs of the roofing material are not made to hold that much weight back. So it's very important that that is dispersed across the entirety of the roof. Same thing here, these homeowners had snow retention on the front, they liked it, so they wanted to run it around the side. With that, they did most definitely see failure when that whole run of the roof was being held by 4 ribs. Upper roofs that shed to lower roofs are also very important, making sure that that's taken into consideration, because that can cause damage whether there is snow retention or not. Ice damming, I'm going to run through these. I'm sure you know what an ice dam is. That heat loss that I discussed earlier about how the ridge of the roof loses the majority of the heat, and as you get towards the eave, it refreezes. That actually is what causes the ice damming concerns. And Europe actually has a pretty good way that they handle ice dams, and it's something that was investigated by our company for a very long time, probably long before we were ever a company. But they utilize low slope roofs in mountainous regions. It's just much easier to hold the snow on a low slope roof. They then equalize the roof's temperature to the outside ambient temperature with a ventilated roofing system. So with that, you're moving a large volume in equal amounts of air from eave to ridge to be able to equal your inside attic temperature to your outside ambient temperature. And then you're incorporating more insulation, so a minimum of R50, and hold your snow on the roof with a snow retention system, creating that insulating blanket. So this just shows two graphs of what that looks like. Your traditional roof system is on the left, where you have those differing temperatures, that water's being created from the snow and ice. That's all melting, becoming water. It gets down towards that eave. It's refreezing, solidifying more into ice. That water's coming back behind that ice, comes out over top as icicles, or it sits behind in that warmer space and just sits there as water on your roof. And that is where you usually see water intrusions start to happen in your buildings, is when you have those ice dams and the water's backing up behind it. So if you're seeing icicles, there's already ice damming that's occurring. Another advantage to a cold roof system is to help with the condensation that occurs when the dew point is reached. The ventilated system does provide a means for that water vapor to escape before it condensates on the back of an attic. So I don't feel like I need to jump further into that. The owner of our company actually wrote a manual on cold roof systems. So I have a very large amount of information on cold roof systems, but I can put you in touch with him if that's something that you want more information on. This just shows the different projects and how this has worked with an issue of snow, being able to have that ice damming and have that water backing up, to building a new property 100 yards apart and being able to prevent all of those things. That does conclude the AIA portion of my course. I do have a little bit of TRA's information that I will provide, but if there's any questions, I can take some of those now.
Right, awesome. We definitely do have some questions. So now is a good time. If you haven't submitted one yet, feel free to do that. If it sounds good, Mindy, I will just start from the top. We'll kind of work our way down.
That's perfect.
All right. Are you aware of any snow retention standards in development in Canada or the USA?
I work pretty closely with a couple contractor associations that have heard whispering of snow retention becoming a standard in some of like the Truckee area and some of that in California. As far as Canada, I haven't heard anything about regulations, but it wouldn't surprise me down the road if it's something that does happen. We're working with the ASTM to help try to create some kind of standard for areas that it's most definitely necessary, but those processes are pretty bureaucratic and they take a really long time. So it will definitely depend from city to city if that changes and how that changes. But I think it's just smart to have those systems engineered. We do it for free. A lot of other companies do it for free. And it just makes that liability go away. If this ever does come to a code or a standard, it will be taken care of before it's a problem.
Mhm. All right, great. Does a structural engineer have to account for the extra weight added by including a snow retention system on a roof versus not including one?
It's a very good idea to do so. Yes, I most definitely always would tell someone to consider that you are holding that snow on the roof. But I also think it's important to consider that weight, whether you're including snow retention or not, because that weight is going to be there and it's going to hold until it randomly slides off. So there's no given point of when that slide will occur if you don't have snow retention. So it's a very, very crucial to make sure you're considering that extra weight load for the winter time period anyways.
All right, looks like we've got a few requests to see if you would be willing to share the PowerPoint slides.
Yes, absolutely.
Cool, awesome. All right. And then should we do anything different if the roof is spray foamed?
If it's, are you meaning spray foamed on the inside? And for snow retention or for cold roof systems? I guess I'm a little confused on that one.
Okay, yeah, Matthew, if you could provide a little bit of clarity there, that would be great. And then we can get that answered for you.
Yeah, of course.
All right, oh, go ahead.
No, it's okay.
So just the next one is, what is the current best practice for flat roofs?
Flat roofs are a little tricky. So it's one of those things, I mean, they're going to hold more snow because there's no slope to allow that snow to come off. But it's really going to depict like your area and those types of things if snow retention is necessary on that roof. So if you're in the Midwest and it's a flat roof, you're most likely perfectly okay. You might get some ice on there, but it's not going anywhere. But everyone's definition of a flat roof is different also. Sometimes a very low slope roof is considered a flat roof. And if you have any kind of slope on that roof at all, you can almost guarantee that snow is going to move at some point, and it just gets a little tricky there. So we do fully engineer systems, and I think I mentioned we do that for free. So if that's something that you have concern, we usually will tell you if we're like, this doesn't need anything here, or you could get away with one bar at the edge just for safety purposes, but it's most likely not necessary. We're pretty straightforward about those kinds of things. And we want to make sure that the snow retention is utilized in a way that's necessary and not just up there for show.
Right. All right. Looks like Matthew gave us some more clarification. So they say spray foamed on the underside of the roof deck inside the structure.
For snow retention, that wouldn't make a difference. For a cold roof system, it would. And you do have to be careful with the spray foam on the roofs, on the back side of the roofs. In a lot of cases, I've actually heard of that happening, and then the temperature changing and it actually just kind of popping the roof off. So make sure that all of the instructions are being followed on those types of materials. And then if you're trying to get a complete airflow into the attic for a cold roof system, you would want that insulation lower, because you're actually wanting to equalize the back side of the roofing material to the outside temperature. So you wouldn't want that insulation to be sitting right there.
Right. All right, awesome. It looks like that has worked through most of our open questions. So while we have a few minutes, did you have some additional items you wanted to share specifically about TRA Snow and Sun?
Yeah, that would be great. So basically, TRA Snow and Sun, we've been in business for over 30 years as a snow retention manufacturer. Our owner and founder was a consultant in the roofing industry for years and had ran into some problems that he didn't feel like there was an adequate solution for in the United States. So he traveled and did some learning and came back with the thought of snow retention and snow brackets specifically. And we do provide free engineered layouts and quotes. We can just add that to your project. We're working now with like BIM files and all of that stuff, so that we can provide that for you in an easier format. We do also have guide specifications, data sheets, and a system warranty if it's installed per the layout. I mentioned the ASTM task group already, but we're just trying to help educate the roofing and design industry of these solutions and make sure that we are being part of the solution as well. Terry Anderson is retired from TRA, but he still does consulting on the side, and cold roof systems are completely his passion. So if you have in-depth questions or concerns about cold roof systems, he is the perfect person to speak to on that. If there's any layouts, whether they go through Acelab or they can go through sales at TRA Snow and Sun, and we can receive those layouts, we usually have about a 2-day turnaround unless it gets into busy season, and we can get those back to you with a quote and all of that information.
Awesome. Yeah, I feel free to get in touch with Mindy directly about taking advantage of some of those free resources. I dropped a link to their page on Acelab in the chat. So if you want to bookmark that, you can head on over there, and you can upload any drawings, get in touch about projects. Before we jump off, we've got about 2 more minutes. So just want to let folks know as you're leaving, there's going to be a quick post-event survey. If you have any questions that are coming up as you're kind of heading out, feel free to leave them there, or any feedback for us about, how this webinar was, if it was relevant to you. That helps us to keep bringing you content that is important to you. So there's a few other things in there. I think Helen's meeting link. So yeah, just grab anything you might need from the webinar chat as you're heading out. And we really appreciate everybody coming out today and asking so many great questions, and definitely get in touch with Mindy to talk about any projects and ways that they can support you. All right.
Thank you.
Awesome. Thank you so much, Mindy. I hope everyone has a great rest of their day.